আপু একটা মিনিট ফোন ধরতেছে আপনাকে।
Okay, I think let's get started. So this one we are going to sort out this.
Okay, let me share my screen.
Yep.
Let me share the window. Can you see my screen?
Yes, it is.
Okay.
Yes, yes.
Uh, Thank you everyone for attending. I sent the link to the slides in the chat. You can access the slide if you want to. And so today I'm going to give introduction to GMap. You might have used Google Engine. You might have the JavaScript API. So I'm mostly going to focus on the Python API. I'm going to show you some of the features that you can utilize. And so lastly, I will have some additional resources. You're going to learn more about the package or some other open source project that I'm working on. And the right shows you on interactive web app that you can use to create time-lapse animations using Google Engine. You can pull up the link, and so here this is kind of the interface. You can just go to the URL and then you can start creating animations using Google Engine, using any satellite you want. You can use Landsat, you can use Sentinel, all kind of time series data. As long as it's available on the Google Engine, you can create animation easily. And so here's the short animations. You can basically just go anywhere and then draw a rectangle, and then you can export that as an ROI, and then you can upload to the web app, or you can just upload something directly from a computer. Then you can select the bank combinations, date and time, and also some parameters. Then just click one button, you'll be able to generate the time-lapse animations for any location around the globe. You can do that for anywhere. You can, like I said, you can use any satellite data, and you can download the animation as a GF on your computer. It makes it really easy. So behind the scene is using Google Engine to do all the computation, and also use GMap to create the interactive web app, and also deploy on Hugging Face using free cloud computing resources. So here I show you some interesting animations. For example, the drawing of the RC, mining in Canada, coastal expansion in Dubai, and also the river dynamics in Peru, the one that I showed you earlier at the beginning. Deforestation in Brazil, landslide, and urban expansion in Las Vegas, in China, in Mexico. This one is in Nairobi, so you will be familiar. It's not very obvious because the urban growth is not as obvious as those in Las Vegas and Mexico, but you can still see some changes if you pay close attention, especially in the south side here, some new buildings, new residential, and also commercial area in the south side of the city. And you can also do environmental monitoring, for example, coastal erosion. And so those are mostly Landsat data, 30-meter resolution back to the 1980s. You can also create animation using any set of data. So this one shows you the temperature changes within 24 hours. So you can create these kind of things easily just with a couple lines of codes using GMap. You can also do ocean temperature mapping dynamics through a longer time scale, for example, by month, by week, or by day, whatever you want. You can also do vegetation monitoring. So this one shows you the phenology changes throughout the seasons in Africa, in China, or you can do it at a global scale. So you can see it's actually very, very interesting when you looking at it from space at a longer time span. Um, Besides those coarse resolution data, but here we also have a lot of high temporal frequency data. For example, the NOAA Ghost satellite, geostationary observation environmental system that allows you to capture images of the Earth every, for example, 5 minutes. So this is very high temporal frequency. But the nice thing about this, you can capture those natural disasters that happens in a short time period, but very, very fast. For example, volcanic eruptions, and also wildfire, for example, on the right showing here. So besides capturing the images, it can also actually do some analysis to extract the wildfire boundaries. So the pink color on the right shows you basically the wildfire spreading. So you can not only do data capture, but you can also do data analytics built on top of the Google Sensing platform. So under the hood, these are all using Google Sensing and GMap. And since this is a Google developer meetup, so you probably already know use Google Sensing. So I'm going to skip quickly to this. The idea is that we are right now mostly doing things in the cloud. We don't use desktop computing to do large scale because you just don't have the cloud computing resources. So Google Sensing is one of those probably the most popular cloud computing platform right now. It's free for research and education. So you can sign up account nowadays using your Gmail, and then you can start doing coding using the cloud computing platform. So these are some of the advantages why you want to use Google Engine. It's cloud-based. You just need a browser, and you can do large-scale data processing at a global or continental or national scale without downloading any kind of data. And it has very user-friendly. It has a huge data catalog. So this is one of the biggest advantages of using Google Engine. It's already there. So the data has over 100 petabyte, 100,000 terabytes. So you can pretty much use any data available in the public domain. And you provide the Python and JavaScript API, and beneath it also has the REST API. And free for research education. On the right here shows you the publications that use Google Engine during the last couple of years. So you can clearly see the exponential growth during the last couple of years. It's going to continue to grow because it empowers researchers to actually do global scale studies very, very easily. So you can focus more on your mechanism, focus on more on answering scientific questions rather than having to manage the data. And so this is one of the simplest applications is to do, for example, cloud removal. So you might have done this. You can point to an entire image collection, then just do a median filter, and then you can quickly create cloud-free images like this, just one line of code. And some of the images, for example, on Google Earth that you see, they probably might have been processed using Google Sensing because cloud is a big problem for optical remote sensing. And throughout the year, you have some in some locations, you really have a cloud-free imagery. And then with just a couple lines of code, you can create cloud-free. You can also create time series cloud-free images by utilizing the cloud computing power to process images by pixel. And then you can get the base quality pixel when you put all the pixels together. Then you become a cloud-free imagery. And so Google Sensing has a big data catalog. It's over 100 petabyte right now, and it's continuing to grow. So it has a tons of data. Most data in the public domain already has that. So if you already use Google Sensing, the JavaScript API, you might have used some of those data. So all you need is to go to the website, search the data, and then you can just import the data into your catalog. So just pointing to the data, you don't have to download anything. And so right now we have Lansec 8 and 9 running, and we are going to have Lansec next in 2030, in 5-6 years from now. And so the resolution is going to increase from 30 meter to 10 meter, and also the spectral band is going to increase from 11 to 26. So the file size is going to increase from 1 to 20 gigabyte. And so right now you're still using some desktop computing. You have not used cloud computing yet. It might be okay if you're doing for a small area, but in couple years when Langsec Next is launched, you will not be able to process the data because one image thing going to be, for example, the same size is going to be 20 gigabytes. So it's going to be much larger. And even if you have data storage, the computing power is going to be very intensive. You're going to try to process, for example, just a small area with 20 gigabyte data. So just to keep it in mind, you need to prepare yourself for the next generation of satellite data. And so this is where GMap comes in. It built on top of Google Sensing. So before we get into that, I would like to point out the differences between the JavaScript API and also the Python API. So if you already use the JavaScript API, you might have know some of these advantages. So the JavaScript API has a lot of documentations. So when Google Sensing will launch, I started using it in 2016, 2017. Most of the documentation were using JavaScript, not very not many examples for the Python API. And it's interactive. It's built-in authentication, so you just need to log into your account using the browser. You also have the Google Sensing app that you can deploy to create web apps that can share with other people that don't have a Google Sensing account. The downside is that you cannot install any additional packages. You're limited to the browser, and you cannot upload data directly to the code editor. To use in the code, you need to ingest into your Google Sensing account before you can actually use the data. And also, there's not really communication with your computer. You cannot use IDE. You only can use the Google Sensing code editor to write code, and the debugging and also the code auto completion is quite limited. So the Python API is more flexible, although it has less documentation. Now it's getting a lot better. It's improved a lot during the last year or two. But you can use a lot more options available for you to use. You can use more IDE, for example, you can use Visual Studio Code, you can use PyCharm, Jupyter Lab. You can also integrate with Desktop.js, QGIS, ArcGIS. You can directly access those cloud computing, and you have a lot more packages available that can do interactive mapping and also plotting. You can also do deep learning. So that's one of advantage of using Python is that there are a lot of deep learning library available. They can makes it easier for you to run deep learning algorithms on Google Science data. JavaScript is not very convenient. So these are some of the advantages of using Google Engine. So this just shows you the interface. If you use JavaScript, you are already familiar. Like you can write code here, and then you can visualize the data interactively, and you can also inspect the result, and then you can show it on the right. So the Python API mostly just for computation. It doesn't really have visualization functionality. So GMap built on top of the mapping libraries, for example, Folium, IPyLibDat, and also utilizing IPyWidget to create interactive widget that allows you to visualize data interactively, and also you can change things interactively. And it's open source, so you're welcome to check out the link. If you know how to do coding, you are welcome to contribute to the project. So all the source code is freely and available. And also, we have a website, gmail.org, that has a lot of documentation that you can learn if you want to. It shows you how to install the packages and how to run the notebooks. So right now we have, I think, over almost 140 notebooks available that allow you to learn the package. And also publish a short paper describing what GMap is about. So it's about 4 years old now. Uh, I created it after the pandemic, and so far it has been used by a lot of people around the globe, and we have created a lot of novel examples, 141 right now, and I have talked a lot about workshops and conferences and at universities, and so it has over 4 million downloads so far, and thanks to NASA for supporting the NASA the GMAP project for 2 years. And so during the last 2 years, we have added a lot of new features and improvement to the package. So GMAP was among one of the some of the popular Python packages that being supported by NASA. And I also published a book last summer. You can check out the book here, the link upper right corner here. All the source code and also all the novel examples are freely accessible. And if you want to purchase a hard copy, you can check out the link on the publisher website. And I'll show you later how to access some of those resources. So those are kind of the introduction to GMap. Next, I want to show you some of the key features, like just to give you an impression about what GMap can do. If you already use JavaScript, perfect. But GMap can make a lot of things easier, just with a couple of lines of code. And so GMap has been officially adopted by the Google and the Earth Engine team. So now if you go to the Google Engine documentation, they usually, for each example, they have the JavaScript and also have the Python example. So the Python example is actually using GMap right now. But the GMap right now you can see has a core component and also extra functionality. So the GMap, the core is supported, officially supported by Google. So it has some features. It's a limited subset of the GMap functionality, but it's more stable. So because it's supported by Google, but for regular users, you can just import GMap and then everything else remain the same. You don't have to do this. But GEEMap core basically is just a sub module of GEEMap that the functionality being supported by Google. And so next, I'm going to show you some core features. So these features basically means that they are supported by the Earth Engine team. So it's more stable. And for example, base map selector, you can just one click, and then you can change base map interactively without coding. And this is not something you can do using the JavaScript core editor because you are limited to using the Google Engine base map. You cannot use other base map. But Python is a lot more flexible, so you can use hundreds of base maps or even your own base map if you have a web map service. So, and beside the base map selector, we can take base map manager, editor, something like that. So on the right here shows you basically the sample. So you can import the GMap core and then just create a map. Then you can point to some data, how you're going to visualize that, and then just map add layer and then display the map. So this is just a simple example. So in between, you can do a lot of things. What you want to do is create a map and then display the map. And then in between, you can write very complicated algorithms to do a lot of computing. And layer manager that allows you to add multiple data layers and you can turn layer on and off. So this provides very similar experiences to the JavaScript code editor, allow you to turn layer on and off and also change the opacity. You can also change the visualization interactively. So for example, you can add a raster data layer and then just select a color map easily. For single band raster, for multi-band, you can also change the band combination easy. So for example, from force color composite to natural color composite or RGB, whatever band combination you want. You can also do vector visualization. So this one shows you, for example, a feature collection, and then you can just with couple click, you can just change the visualization easily, and then you can also click the import button to get the source code, and then you can put it into your source code to reproduce the output without having to use the interface. You can also do inspector, so similar to JavaScript, that you can click and then you can get any vector and raster pixel values and also vector attributes. So very easy to do without having to do a lot of coding. And also we support the dual control, so that means you can use the dual control to create Earth Engine feature collection, and then you can use that to do clipping or whatever you want. So it's very flexible. So all the core features trying to provide similar functionality to the JavaScript core editor. That if you already are familiar with JavaScript, you might find also the GMap core functionality very easy to use because they are very similar. So those are the core functionalities, and GMap has a lot more extra functionalities. As I mentioned earlier, it has over 140 notebooks. So each notebook will introduce one or two new features of GMap. So this probably shows you on less than 5% of what GMap can do. But those are some of the highlighting features that people find it very useful. And similar, here they just show you the example. You can create a map and then you just point to the data and then you just add that, the same thing. Rather than import GMap core, you just import GMap. So and then you can have the full functionality. So the first one here is the converting Earth Engine JavaScript to Python automatically. If you have any JavaScript example, you can just copy and then paste, and then just one button, it will help you convert to Python. And of course, it's not 100% perfect. Sometimes you might need to do some modification, but most of the example from the Earth Engine documentation, you can just copy and paste. You will be able to convert it automatically. So as you can see here, just one button, then you can, even if the Earth Engine documentation doesn't provide the Python examples, as long as it has the JavaScript, you can convert it automatically. So this one is allowed you to source data. So you can source by any keyword, and then you can select from the drop-down list and just one click, import the button, click the import button, and then you will generate the source code, the example, basically converting from the JavaScript examples to Python, and then allows you to load the data interactively. So as you can see here, you can source any data. So it has over 100 petabyte of data. So all you need to search, and similar to JavaScript, you can just load the data interactively without having to do coding. So this makes it really easy for people that are not familiar with cloud computing, but you just want to type some data, source some data. All you need is just create a map, just 2 lines of code, and then just click one button, and then you can source data, and then you can load the data. Kind of like you can source the movie on Netflix and or YouTube. and then just click, and then just play the video. It's kind of like that, but it's doing that for geospatial. So you can basically load any geospatial data easily using the browser and within GEEMap. Um, and you can also create color bars. So if you're trying to create some visualization, and you can create a color bar just one line of code. So it can be vegetation data, it can be elevation, it can be temperature, it can be anything, one line of code. So this something might be quite challenging to do using JavaScript. You might need to write a lot of lines of code, but in um, GMap is one line of code. You can also do plotting, so you can create spectral signature, for example, like this without coding. So only just load some data and then just one button, then you can create this kind of spectral signature easily. You can do also hyperspectral. So if you have a lot of spectral bands, you can also do that easily. And you can customize the plotting. So again, no coding, just load data. That's it. You can visualize time series. So if you have, for example, this is the vegetation, daily vegetation, and you're trying to visualize the data layer. So what we need is just a time series collection, and then just one line of code, you can create this kind of animation. So in that way, you don't have to load all the individual layers. All you need just um, one image collection, and then just add one line of code. Then you can visualize that easy without having to add a lot of data layers to the map. You can also get a so-called time series inspector. So you have two image collection that you want to compare data side by side. Again, this is just one line of code to create something like this without having to write many lines of code. And you can do it for use length cover. You can do it for temperature. You can do it for any image collection. You can also have a satellite image collection on the left, the other one on the right. So it's very flexible, and you can create, for example, global link cover data set and do some comparison like this very easily just with couple lines code. So GMap has some functionality that allows you to create link cover, for example, using the dynamic world data set easily. And you can then use some of those visualization tools to quickly compare the data set for different data types. You can also integrate GMap with ArcGIS. So all you need is just to install the package in ArcGIS Pi environment, and then whatever data layer that you load on the Jupyter Notebook, it will be added to the ArcGIS Pro um, data layers. So in that way, you can use Google's engine for cloud computing, and once you generate the results, you will be added the layer to the map. So then you can use ArcGIS to create maps, because GMap or Google's engine not for creating fancy maps. It's mostly for cloud computing. But if you want to enjoy the benefit of both desktop and cloud, this might be useful for you. Also, you can use QGIS. There's also a Earth Engine QGIS plugin, also allows you to access the data layer, Earth Engine data layer in QGIS. You can also create maps with custom projections. So if you are interested in generating some maps for your publications, you can also do that. This you need to write a couple lines code, but it's doable. So you are welcome to check out the noble examples and then try to customize your own data, and then you can create these kind of projections for depends on the location and the area. You can create it if you want to. So without using desktop JS to create those maps. And you can also create time lapse directly within the GMap interface. So at the beginning, I show you the interactive web app that you can use to create apps, but GMap also has the built-in functionality. So you can just one click, and then you can generate the animation for any location. The nice thing about this is that the animation is overlay on top of the base map. So you can actually zoom in and zoom in to any location, and then the animation also will be overlay on top. So you can also zoom in and zoom out directly on the map. So in that way, you can overlay on top of this, and then you can compare different data layers. Again, this is also no coding, but you can just create a map, and then you can zoom to any location. Then you can start doing creating those animations. Last one, if you are interested in sharing your stuff with other people, so you can also create web apps using GMap and then deploy in the cloud. So this just shows you an example. So everything in doing here is free, so you can just use the template, and then you can just create a web app and then deploy. So you can share the link with anyone that want to access your web app, and they don't have to have a Google Engine account. This is similar to the Earth Engine JavaScript web app that you create and then you can share with other people. So in that way, people don't need to know coding. They can use your web app to create something like this. So those are some of the key features I want to show you. Of course, there are a lot more features available, so you're welcome to check out the website. So next, I'm going to show you some additional resources. You can check out this Open Geospatial GitHub organization that I created. And so it hosted a lot of packages that I created. GMap is just one of those. So I also have DeepMap, Geospatial, and segment geospatial. So we're going to try out some other packages that you might find interesting. So the packages basically allows you to do visualization and also analytics. Also created a lot of data catalogs. So not just for Google Engine, but also there are a lot of data from NASA, from Microsoft, and also from AWS. So this data catalog makes it easy for you to actually see what data are available. So you can also develop tools that to access this data, visualize the data, and also analyze the data. And lastly, I have some web apps template. So on the right here shows you web's template created using, for example, Streamlit, Solara, or Voila. So there are different ways you can make your things accessible to the public. And so what you want to do is to depend on what you want. You can use one of those template, and then you can just customize it with your own data. And so um, I also have a YouTube channel that I posted a lot of tutorials on Google Engine, GMap, DeepMap, or database, all kind of open geospatial stuff. So if you're interested in, you're welcome to check out the YouTube channel for more video tutorials. So there's a couple like workshops that I taught in the past that if you want to learn more about GMap, I recommend you try it out. So this is the workshop that I taught last year at SciPy. So it has a 3 hours workshop, and I also taught at Google the last year for good last October, and it also has I think 3 hours of workshop. So you're welcome to try out this series of workshops. So these are pretty good quality that recorded by Google, and then with some video editing. And the last one here, the latest one, is the one that I talked last week. So it's only a couple of days ago at the Indiana GS conference. So this one is 5 hours. So give you a comprehensive introduction to Google Engine and GMap, and it has a lot of practical examples. So also the notebook, so you can check out the video and then learn some of the key features using GMap. Get your hands on, and then so you can not just so most of the features that I showed you earlier is covered in the notebook. So you pretty much learn everything that the key features that you want to learn about GMap. And so that's what I want to show you. So next, let me head over to GMap. I want to show you some resources here. So if you go to gmap.org, head over to the website, and you should be able to find the documentation here. And as I mentioned, you can check out the notebook here on the left side. So right now it has over 141 notebooks, and you can also look at some of the workshops that I taught in the past. There are a lot of workshops. So for each one, you're going to find a notebook example in here. And these are pretty long notebooks. So for example, the one I mentioned, this one was just last week, 5 hours. So you get to a lot of examples that you can use, and you can just change it to your own area. And so if you're someone that you can also do the source. For example, you can just, for example, lens set time lapse. So if you want to create time lapse, you can use this search function, and then you'll be able to see all the source code available. Then you can learn it if you want to. So they are all the source code is available directly from the source. And you can try out, for example, click the tutorials. So this one also shows you all the notebooks examples in a list. So if you want to search on the page to find some examples, you can do that as well. Last one, the book. So if you're interested in learning more systematic way, then you can check out this book. All the source code are free and open access. If you want to buy the hard copy, you can check out the publisher website. So each one here, you can see the table of contents. So we have 11 chapters, I think total like almost 400 pages. So you can check out the source code here. You can navigate each section, and then you can check out the book content. So the first one has text source code. For other chapters, only have the source code. So if you want to see the images, the figures, and also text, you need to go to the publisher website to purchase a copy. But all you need to do is just to go here, and then you can go to the GitHub website, or you can open it directly using Google Colab. So for example, here you can click open Google Colab, and then you can just start running through the source code because GMap has been pre-installed in Google Colab, so you don't have to install it. All you need is just click run, then you should be able to utilize it directly. Of course, you need to authenticate your Google engine and also initialize, but you don't have to install. You see, I just import it. I don't need to do anything. So you can just import the library. That's it, and you need to authentic your account to be able to use it. But it makes it really accessible, so users don't have to install packages on their account anymore. They can just run the code and then you can test it. You can also go to the GitHub. So here, if you go to the repository, you'll be able to get access to all the source code available. So you're welcome to ask questions here. If you have any questions about um, the books, and all the source code is under the notebook in here. So all the notebooks and also the markdown. So if you're someone that want to get all the source code all at once, then you can go to my GitHub repository to download all the source code. And so all you need to just run through the examples and then try it out. And I welcome your feedback. So these are some of the additional resources I want to show you if you want to learn more. Again, it's for today's presentation, I cover some of those, but not everything. So you're welcome to check out the notebook to see more details about GMap. Okay, so that's all I want to share with you. Happy to take any questions.
Okay, so thank you very much, Kushi, for this session. That was really great, and we do appreciate. In fact, what we wanted to mention to our members is that you approved our request to have this book published in our site, and this was a great opportunity for our members to have access to this book. So what I'm going to do is just to share the link to our website in the chat, so that anybody who could have missed could also access the book to that through the community website. Meanwhile, we could have the questions from the members. If I could see some of us have questions, have raised their hands, so we can just get started by Harry. Marvin, please, maybe you can just open up your mic and go on with the question. Yes, Marvin, please.
Yeah,
Okay,
can unmute.
can we
Yeah.
Hello.
Yes.
Uh, I want, hello. I wanted to ask about uh, battery buffering.
About what?
Hello.
Uh, we lost you.
Okay, maybe you can type on the chat. Can we have Emeka, please?
Yeah, hello. Can you hear me?
Yes.
Yes.
Yes. Hi, Doctor. Thank you for um, this lecture, and thank you for the community of GMAP that you've been pushing. I've been following most of your work. You did one of your course with United States University.
Uh-huh.
Um, was this Water University of UN University,
Uh-huh.
basically, and I've been following your work on YouTube. So
Mhm.
I don't know. I want to know, in case we are having issues when we are using the GMAP.
Mm-hmm.
For example, I was working on a research recently on drought analysis. I was trying to work on vegetation condition index. So I was using the GEEMap zonal statistics
Mm-hmm.
by group, but I noticed it wasn't giving me the number of classes that I have on the raster. So after converting it to FC, which converts it to a shapefile, a vector, or a feature class, I noticed the number of classes that I have, because when I reclassed the
Mm-hmm.
raster image from 100 to 6 classes. So on converting it using the zonal statistic, I was getting just 4 classes. So in this kind of issue, is there a place where we can, a community where we can drop this kind of question? Just because I've been working on it for over a week now
Yeah.
without an
So
yeah.
here, I recommend you just go to GitHub, go to the website, and then click on the GitHub. And there's a discussion board here. If you click the discussion, here's where people ask questions. You see, I answer questions every day. So if you have questions, you can post a question here, and then also provide some sample codes, and then we'll be able to help you out and provide
Okay.
examples. So specifically
Uh,
for the question that you're asking about the zonal statistics, uh, you
yes.
can you can go here, for example, um, zonal statistics, right? So here's the
Yeah, by
um,
group.
I think let me source the source this zonal statistics by groups here. So you can look at the source code. I think what you need to do is to specify the scale. By default, it's none. I think
Yes, yes.
look at it, just
Yeah,
specify this one. By default, it's probably
yes,
10 times of the scale,
yes.
so it's like cost resolution. So sometimes we sample and then skip some of the smaller classes. But if you want very detailed, then for example, using laser, you can specify 30 meter, whatever resolution that you need. But keep in
Okay.
mind, the larger the
Yes.
number, the higher the resolution, the more likely you're going to run into memory issues. But if you just need a rough estimate, you can keep this one as none. But if you want very accurate, then you specify a number, but you might run into memory issues when you specify a
Okay.
small number for a large area.
Oh, okay, okay.
Mhm.
So I'll just drop the question, because what I was using was the Modis vegetation one
Yeah, then you
kilometer
set to 1,000.
testing days. Yes, so I set it. I set the scale to 1,000. I
Mm-hmm.
wasn't trying to download it. What I was just trying to do was to convert it into a data frame, so I
Mm-hmm.
could get like a graph just to
Mm-hmm.
show trends by
Mm-hmm.
states. Yes. Maybe I'll
Yeah,
just
change
drop
to
the question
1,000,
and drop
and
my
give
code.
it a try.
Yes, I did it to 1,000. I think
Mm-hmm.
I'm not really sure, because I know I specified the
Mm-hmm.
scale, I specified the region, that's the region of interest, so that it's I
Mm-hmm.
specified everything. So I wasn't really sure
Mm-hmm.
how would have been. But thank you. I'll check the GitHub, or if possible,
Mm-hmm.
I can share my code. I don't know.
Sure, yeah, just ask a question on GitHub, then we can help you from there.
Oh, okay, okay. Thank you very much, and thank you for
Mhm.
your work.
No problem. Next one.
Yeah, Ilana, please. So I can go on to Heidi.
No, no, can you hear me?
Yes.
Yes.
Yeah, thank you for the presentation. It was really amazing and really
Mhm.
great. Thank you. Actually, it's really very interesting work. I just have two questions. The first, like it's like this platform.
We lost you. Or is it just me?
No,
Not
it's not
you.
just you.
I
Yeah, I
think it's
cannot
just
hear
you.
anything.
Okay. While she comes back, we can have Irene, please.
Mm. Hello, good evening.
Mm-hmm.
Thank you for
Yes.
the presentation. My question was brief. I've been trying to initialize the Art Engine library on my Jupyter notebook, even after authorizing it by inputting the code that is being redirected. I wasn't able to run like it. I got stuck there. It's not
So
working.
just
So I
like I
don't know.
mentioned, ask on the GitHub discussions. You can post questions there. It might be your account problem. It might be how you set it up. So just provide the screenshot and the source code that you use to authentication. We can help you from there. Right now I cannot see, so I don't know what exactly the problem is.
Okay. Should I share my screen?
Yeah, if you want to, it's up to you.
All right. There is it. This is where I got stuck. I don't know if you're able to see my screen.
Hmm.
This is where I got stuck. I couldn't run this code from here.
What do you mean? So it's already authenticated. Do you run again? So run the code block.
Sorry.
Yeah, run. Do you run it? I don't see you run it. So
Okay.
authentication is only one time only. You don't need to authenticate all the time. It's just one time only.
But it's not picking on the second code. That was my
What do you
issue.
mean not picking on the second call?
After initializing and authorizing with the code, nothing's happening from here.
Oh, you need to click and then join the authenticate. Just
Yes.
uncheck the E authenticate. You don't need to run it all the time. It's authentication is only one time only. You don't need to initialize for every notebook.
Okay.
And you cannot just use E dot feature collection and then just passing your local file pass a straight file. You need to use GEEMap.
That's okay. That's okay.
So
I
basically,
will
go to
try.
the GEEMap website, check out some of the notebooks. Basically, your source code is incorrect.
Okay.
Mhm. So go to the Google Engine, the GEEMap website, try out some of those notebooks. You can try out in Google Colab directly. This is not really a GEEMap problem. It's more like how your source code problem.
Okay. Okay. I'll try on my own time then.
Hmm.
I will try reach out for help.
Okay.
All right. Thank you.
Okay. So we can have Helena, please. Oh, Dennis, let's see you.
Hi, Prof. It's a really good pleasure to have you here. I'm a student as well, following along your YouTube channel on the
Hmm.
UTK website. Really
Okay.
cool
Thank
stuff,
you.
the things you
Hmm.
do on the summer. Two questions. One, how would you suggest we handle proprietary data, and especially specifically data points or surveys that would be covering personally identifiable information for like points or whatever, while trying to build these up? What would be like just your general suggestions and offers, and maybe the second question would be, is it possible to just send you my mock project that I'm using following along your lectures at the UTK GE geographic software development course that you're offering as well?
What's the second question again? Saying what?
Are you open to maybe take a peek at my project that I'm doing following on your lectures for the UTK course that you are working on? I know it's like, a course that you're doing with your students and everything, but the
Yeah, you
lectures
can share
are,
on the GitHub. So there's the course website. You can, if you have something to share, you can share on the GitHub website. If you want to share like the project that you created, yeah, you can share on GMap website, also on the software design GitHub website. There's a GitHub discussions that you can share whatever you want to share with other people.
okay, cool. Thanks.
And for the first question about some private personal data, you can just upload to your Google Sensing co-editor, and by default it's private. So as long as don't share with anyone, then the data stay within your account. And certainly, I mean, nowadays nothing is really private. Nothing is really 1%. As long as you use cloud. So just like you upload things to your Google Drive, it stay within your Google Drive. You don't share with other people, then it's yours. But I mean, Google knows a lot about you. So even you don't share with other people, they might know the data. So it's up to you what you want to whether or not you want to trust those big tech. If you trust them, then you can upload data, and then as long as you don't share with other people, it's yours. Then you can use that within your Google Sensing algorithm development